All right, so let's try this one. Just a simple fallback function exploit. It's the same story as in general as before. We're going to have a fallback function here. And in this case, you got a contract, and the constructor makes it owned by the person who paid the gas to deploy it, which makes sense. But there is a fallback function where if you send in money greater than 0, you become the owner of the contract. And this is the kind of dangerous booby trap that people put in functions. Remember, I talked about rug pulls, where you invest in something and then the owner just steals everything. Now, a properly designed DAO would not have that capacity. You'd only be able to affect your own contract, but you could put in a poison pill like this, where there is some function in the contract which would let the owners, somebody else, steal all the money. Yeah, sometimes it's in there by mistake. Sometimes it's in there by deliberate, so they can steal the money. And this is why the rule is you're supposed to audit the source code of any smart contract before you invest in it. But obviously people don't. Anyway, so there's the function, and this is going to be fallback.solve. So let's go to my functions here. And looks like I don't have a fallback now, so I'm going to add one. Fallback. I spelled it wrong. I don't think it matters. All right, there it is. All right, and now I'm going to compile it. All right, and it's got warnings, but no errors that would be read. Here's the warnings. It has a payable fallback function, but no receive either function, which is strange, indicating the kind of vulnerability, one part of the vulnerability. By sending money, I'll execute that fallback contract. And there's an unnamed return variable. All right. So those are pretty minor, and they're not stopping me. I've still got old stuff from the previous project here, so I'm just going to go to Berlin and back to London to get a clean blockchain. And then I can deploy the fallback function. It's deployed correctly. So down here, I've got various functions I can call. All right. And let me check my instructions. And by the way, here's when the fallback function is used. If you call a function that doesn't exist, or you call it without passing in the required data, or you just send ether without any data, those will all be processed by the fallback function. So compile it and deploy it. Now say 10 ether and contribute 10 ether, okay? So I deployed it from this address here, 5B3, so I should be the current owner. Let's check. Yep, the owner is 5B3 because I deployed it. All right, now if I put some money in this contract because I'm going to use it for something, so how much did I say? Not that it really matters, but 10 ether apparently. Yep, okay. So contribute 10 ether. Contribute. The transaction succeeds. The contract's balance, thought it would go up to 10. Well, and my balance fell. Yep, my balance fell to 10, so maybe that balance there is not showing the contract balance, but anyway, that's fine. So 10 ether left from me, and it went there. At the lower left, click the, get balance. That's right, I remember this. There's 2 steps. You have to perform a get balance to measure the balance, and then you can see the balance here. Okay, there it is, 10 ether. So I put 10 ether in, and now this contract can do things like whatever my contract is for, which is the code isn't here. But now the point is the owner should still be the same, 5B3, which is the correct owner. And now we're going to perform the attack. They want to run the fallback function. That'll make you the owner. So I have to send some ether. So I change to the second account and send 1 ether. And now I go to the low-level transactions here, which will just send money without calling a function. So let's do that. I go to the second account here, I send 1 ether. And now I send it directly to the contract, which I think I'm going to need to copy that address in there. No, I guess not. Okay. It'll just send the ether to the contract. Okay. So I send it with low-level transactions and it succeeds. And now the owner is me. So that's it. By just doing something that the developer apparently didn't expect, sending ether without calling any of these functions, I was able to change the owner. Now I own it. And the contract now has a balance of 11, of course. If I get balance and then look at balances, because there's 10 from the original person and I sent one more to steal it. But now all those 11 belong to me. And if there was a withdraw function, I could withdraw it and I would get the money. So that's the game. And now to steal it, there is a withdraw function. Oh, good. So I can steal it. Let's do that. Now I'm the new owner. I can withdraw it here. There's 11. So let's check. My current balance is 98, 99 approximately. So if I steal 11, I guess I'll get up to 110 approximately. So I withdraw. Now, if I get balance and check balance, it's 0. So all the money has been removed and my contract is up to like 110 ether. So that's cool. I managed to steal 10 ether. So that's all. A pretty simple little attack. Really a booby trap function in the contract.